Elon Musk has just stunned the entire auto industry by confirming something never seen before in a budget. Tesla, a 0.9-meter gap in the all-new 2026 Tesla Model 2's chassis design. Some people are excited, others are skeptical, and many are quietly wondering, will this stitched-together frame hold up when it really matters? But remember what Musk once said, not just about revolutionizing car design, but also transforming how cars are built. Big changes often come with big doubts. And this design gap has triggered one of the most intense safety debates Tesla has ever faced. Today, we're digging deep into all the exclusive test data, proving this bold new chassis is actually stronger than the old-fashioned welded frames you're used to. If you're one of the 137,999 people who never want to miss out on real breakthroughs, hit subscribe and let the bell do the rest. Let's get into it. First, why would Tesla choose megacasting over the traditional welded frame method? Why change something that's been used for decades? The answer lies in something many car buyers never even think about, but it could be the difference between surviving a crash and not. Here's what car companies don't usually talk about when it comes to how your car is built. Most vehicles on the road today are made from about 400 separate stamped metal pieces, all welded together with thousands of individual welds. In a standard sedan, that adds up to around 400 stamped components and about 1,600 weld points. That's 1,600 chances for something to go wrong. That's 1,600 weak spots in the structure meant to keep your family safe. Now let's do some math. Each weld has a failure risk of around 0.5 to 1% under high-stress conditions. Multiply that by 1,600 and you're looking at a serious structural risk that no smart engineer would ignore. And safety isn't the only issue. These welds are also expensive. Each vehicle needs an extra 2 to 3 hours just for the welding process, which adds $500 to $1,000 to the total cost. That money eventually comes out of your pocket. Think about that, a car held together by thousands of little weak points. Would you feel confident driving it? This is why Tesla made a move that caught the auto industry off guard. They completely threw out the old playbook with their megacasting method. Instead of welding hundreds of small pieces, Tesla uses giant 6,000 to 9,000 ton casting machines so big they need their own buildings to create the front and rear underbodies as solid, one-piece aluminum sections. This change reduces 400 separate parts down to just 2 or 3 major castings. The result? Assembly time is cut by 30%, and production costs fall by up to 40%. That alone saves between $5,000 and $7,000 per Model 2, making the sub-$25,000 price point not just a dream but a real possibility. Now, here's where the 0.9-meter gap becomes key. Old-school thinking says more welds make a structure stronger, but Tesla's engineers found the opposite to be true. With the Model 2, they cast the front and rear sections as huge aluminum pieces, each around 0.9 meters wide, where they connect with the battery pack. This battery pack isn't just for power ITs, a tough, load-bearing floor that ties everything together. That 0.9-meter space is the heart of the whole design, where everything meets and becomes one super strong structure. Instead of 1,600 small welds, you now have 3 major carefully engineered connections that can take on forces that would break regular joints. This approach changes everything. According to Musk, a traditional underbody made from 400 parts weighs about 270 kilograms. Tesla's megacast underbody, only 198 kilograms, a 27% drop in weight. That means faster speed, longer range, and fewer things that can break over time. By cutting 72 kilograms of useless structural weight, Tesla is not just boosting performance, they're changing what's even possible in modern car design. And it's not just about speed or savings. For families living on tight budgets, saving $5,000 to $7,000 could mean finally being able to afford an electric car. When you combine federal and state incentives with Tesla's low-cost manufacturing, the Model 2 might soon be available for under $25,000, finally making EVs accessible for working-class families. Let me ask you something. If you knew your car's structure was built from hundreds of small pieces and thousands of welds, would you feel safe driving over potholes or bumpy roads? Or would that make you nervous? Drop a comment and type megacasting if you're ready for this bold new way of building cars. So, how strong is that 0.9-meter gap compared to all those welds? It might seem unlikely, but fewer joints can actually make a stronger car. This isn't just a wild theory, it's supported by serious engineering. For years, we were told more welds meant better safety, but Tesla discovered the truth is the exact opposite. The real problem isn't too few joints, it's having too many weak ones. Tesla's custom aluminum alloy is a game changer. It has yield strength ratings between 140 and 175 megapascals with electrical conductivity between 45 and 55% of the international standard. Most car makers use aluminum that maxes out at 90 to 120 megapascals. That means Tesla's metal is up to 40% stronger than what's in most cars today. These strength numbers aren't just technical jargon, they decide whether your car holds up in a crash. Now think about how Tesla connects their castings. Instead of tiny 2mm welds, they use strong aerospace-grade adhesives and bolts rated at over 1,200 megapascals. That's enough to handle over 30,000 pounds of clamping force. The area where the castings join is about 2.7 square meters compared to a weld's tiny 2mm bead. That's more than 1,000 times the stress distribution area. This isn't just strong, it's overbuilt to survive. Impacts traditional frames couldn't. Real-world data backs it up. Tesla says the Model 2 has 30% better torsional rigidity than the Model 3, which means the car resists twisting and keeps its cabin safe. At the same time, the chassis is 20% lighter, cutting from 225 kg to just 180 kg. Less weight doesn't just help with range and speed, it makes it easier to control the car in emergencies. Production is also much faster. While traditional welding takes 6 hours per car, Tesla's megacasting can make a front or rear section in just 10 minutes. That's a 36x boost in speed with better quality. For everyday drivers, this means safer cars that are built quicker and cost less. And when crash forces hit that 0.9-meter connection, they meet aircraft-grade materials, spreading the impact over a huge area. This is why other car makers are racing to copy Tesla's approach. They know welding is on its way out. And with Tesla's alloy being 40% stronger than most, would you feel safer driving your family in it? Let us know by commenting 0.9-meter if you're following along. Now let's go even further. How can a chassis made of several pieces be stronger than a single steel frame? Isn't it bound to crack? That fear is real, but here's the truth. Tesla's hyper-shear bonding system uses aerospace glue with shear strength of 30 megapascals, the same stuff that holds planes together at 35,000 feet. Combined with high-strength bolts, these joints are stronger than the metal around them. Precision laser-guided alignment places every part perfectly, reducing stress spots that usually cause welded joints to fail. Tesla's own tests are the Model 2 hits 35,000 Newton-meters per degree of torsional rigidity, while the Model 3 only hits 26,000, a 30% jump. That means it bends less and stays solid in accidents. They've done 40,000 virtual crash tests, plus real ones at 64 and 72 kilometers per hour. The Model 2 absorbed 25% more crash energy and reduced cabin damage by 15%. That's not a patchwork, it's a fortress. The 0.9-meter gap is no mistake, it's smart design. The battery pack adds even more strength, about 10,000 Newton-meters per degree. That's another 20% improvement. Tesla's method is inspired by biology like a spine. The castings are like bones. The joint is like your spine's discs. It's flexible and strong. Your spine doesn't break because of joints, it stays strong thanks to them. Here's something wild. Tesla tested this in the Cybertruck, which took 50 kilometers per hour off-road hits without breaking the casting joints. If that monster can survive, the Model 2 will be just fine on city roads. And for families thinking about repair bills, megacasting is a money saver. It cuts maintenance costs by 20 to 30%. That's $500 to $1,000 saved every year. Fewer parts mean fewer things that can go wrong. And if damage happens, Tesla uses modular parts that are cheap and easy to fix. Minor damage costs $200 to $500, way less than the $1,000 plus you'd pay for normal repairs. Even large castings are easy to replace. This stitched chassis is not a weakness, it's the future. It's cheaper, tougher, easier to fix, and safer than anything we've seen before. That 0.9-meter gap isn't a flaw, it's a breakthrough. It makes the Model 2 lighter, safer, and more affordable to build and own. Now you know what that mysterious gap really means. It proves the 2026 Tesla Model 2 is built with engineering far beyond what we're used to seeing in budget cars. This frame wasn't stitched to fail, it was stitched to protect. If this answered your questions, let us know below. Do you trust the design now? Just comment yes. And if you want to catch the next big Tesla reveal, subscribe and let that bell quietly keep you updated. Stay tuned. Music.